So after watching this video, you should be able to define the mean and median and the mode as measures of central tendency. You should be able to calculate the mean from raw data and from frequency distribution tables, and also determine the median from raw data. Alright, so there are three main measures of center that we use to summarize data. So the mode we've come across already, and that's just the most common score. The median, which is the middle number, and the mean, which is, we call it the average, or you might think about it as the expected value. They're each referred in different contexts, and they all describe a set of data in different ways. The key thing is they're all called measures of center, because that's basically the center, the main point where most of the data is. So that's what we want from our measures of center. The contexts are different. In sports, usually I like using averages to talk about the number of points a player might score a game, but in something like house prices, they use median rather than mean in that situation. We'll have another lesson after this one that looks at when to use mean and when to use median, but for now we're just going to look at how we calculate and determine those. Right, so the mean is also just commonly called the average. Right, it's calculated by adding all of the data values and then dividing that number by the number of data values in the set. So we've got our little formula here, x bar, that means mean or average, and that's the sum of all our data points divided by the number of data points. Same, just a formula version of that sentence just beforehand. So looking at an example, we've got a data set here, and we want to find the mean. So we need to work out how many numbers there are. In this case, there are 16 numbers. So n is just the number of numbers in the set. There's 16 of those. So to find the mean, we need to add all those numbers together and then divide by 16, which is just 31.5. And that's our average for the data set, or our mean. Now the mean can also be calculated from a frequency distribution table by adding an fx column to the right end of the table. And in our fx column, we basically take our frequency and multiply that by our score. That's all the fx column does. Alright, so for the frequency distribution column, we want to calculate the mean. Now our fx column, we just take our score, so that's our x column, and then we times it by f. So 1 times 8 is 8, 2 times 12 is 24, 3 times 9 is 27, and then 4 times 6 is 24. Now in our formula here at the very top, we've got this sigma notation. It's the Greek letter S. That just means sum of. So we've got the sum of our f of x column and the sum of our f column. If we sum our f column, that adds up to 35. And that there is our number of scores. Okay, so there's 35 scores in this particular data set. Now this fx column is basically saying if I've got 8 ones, then adding all those ones together should give me 8. Now if I've got 12 twos, adding all those twos together should give me 24. If I've got 9 threes, adding all those threes together, they give me 27. And in the same way, if I've got 6 fours, adding those 6 fours together gives me 24. So basically the fx column is adding up all our scores. And then we just need to add them all together. 8 plus 24 is 32. 32 plus 27 is 59. 59 plus 24 gives us 83. So then to find our mean, it's the sum of our f of x column, which we got was 83, divided by the sum of our f column, which is 35. 83 over 35 is 2.37. And so that's how we find the average when we've got a frequency distribution table, just by adding on that fx column, which is our x, our score, multiplied by our frequency, adding them up and using our formula. Alright, finally we've got to do the same process, but when there's grouped data like we've got here, on a range between 0 and 10, 10 and 20 and so on, the question is, well, which score do we use for our fx column? And the trick is you just use the middle. So if you've got grouped data between a range, pick the middle number and that will be your x value. So the middle of 10, 0 and 10 is 5. The middle of 10 and 20 is 15. The middle of 20 and 30 is 25. The middle of 30 and 40 is 35. And then we just apply our fx scores again there. So 9 times 5 gives us 45. 14 times 15, that'll give us 210. 2 times 25 is 50. 5 times 35, 70, 140, 175. And then we just use the same formula we used before. So the sum of our f of x column divided by our sum of frequency. Sum of frequency column is 23, 25, 30. And then the sum of our fx column is 255, 305, 480. So we've got 480 divided by 30, which is equal to 16. Okay. A nice neat answer for us as we get through that one there. Alright, finally the median. So the median is our middle score of a data set. Now the key thing with the median, the scores need to be placed in order first. So from smallest to largest, and then the middle score identified. Now the middle score is going to be the n plus 1 over 2 data value in the set, where n is the number of data values in that set. If there are two middle numbers, the median will just be an average of those two data values. Right, so looking at an example, we've got our data set from before. The problem is it's not in order. So our first step is to put it all in order. And then our next step after that is to find out, well, which score is going to be the one in the middle. So we knew there were 16 scores. So 16 plus 1 is 17. 17 divided by 2 is 8.5. So the 8.5 score is going to be our median. Now, what does that actually mean? Well, looking at our data, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So our 8.5 score is going to be smack bang in the middle of our 8th and 9th score. So the average, so our median, will be 33 plus 35 over 2, which is going to be 34. 34 is the score right in the middle between 33 and 35. And that's how we calculate a median. Alright, so after watching this video, you should be able to define the mean and median as measures of central tendency. You should be able to calculate the mean from raw data and from frequency distribution tables, and then finally determine the mean from raw data.